Hello everybody. So what we have learned in the first four modules is getting us to the point now where we're actually going to start getting into inferential statistics. And this short module, somewhat short compared to the others, is going to be our introduction into sampling. And we will follow this up and get into some statistical tests here pretty soon. But let's talk about, first of all, the goals of our module. And we'll revisit these at the end, but our first goal is to distinguish between what a population is and what a sample is. Describe the role of sampling in inferential statistics. Discuss four common techniques used for sampling. Explain the importance of representatives in forming a sample. Determine an appropriate size, little n, for a given population of size big N. Explain the general relationship between sample size and size of population. Identify biased samples. Identify important characteristics important characteristics of random sampling. Discuss the role of computed statistics in inferential statistical work. And finally, contrast statistic and a parameter. Should be a singular thing there. So that's what we're going to do in this module. So let's look at the components of statistics. Now, up until this point, the first four modules have been looking at that top branch there. We've talked about descriptive statistics. We went in the first three modules onto the very top there in group and looked at distribution and summary. Then in the last module we moved down into individuals. Okay, and just to touch base with this, the way we did this is we looked at things like mean, median, mode, variance, standard deviation, and those are all summary statistics. On the individual side, we looked at z-scores and probability, and once we had those, we could determine where individuals fit within groups. Now we're going to look at the other side of this tree and go to the lower side, and that's the inferential side. And so this module is going to deal with the first block there under inferential, and that is sampling. And then we'll get into the estimation and hypothesis testing later on. So let's talk about sampling then. So two important terms that you need to know: population and sample. So a population then is any well-defined set of elements that have at least one common characteristic. So this could be something like the senators currently serving in Oklahoma City. It could be the cars in the student parking lot. It could be all freshmen at NSU, or all freshmen in Oklahoma, or all freshmen, college freshmen in the United States. Whatever our common characteristic is will determine what our population is. Okay? And later on, we're going to see that our population, part of that characteristic is going to be something we want to generalize to the population. So depending on what we are really wanting to study may determine our population. For example, I said our population could be freshmen at NSU, it could be freshmen in Oklahoma, or it could be college freshmen in the United States. It would depend on what we're wanting to study that would determine which of those would be our population. So then a sample comes in when this is a portion or a subset of the population. Okay? You could discuss all students at NSU as the population, 8,000 or so, and choose a sample choose to sample the freshman class, okay? Later on, we're going to talk about representative populations. So if we wanted to study the freshmen at NSU, then we could take a sample of the freshman class. So you may be asking yourself, why are we taking a sample instead of just looking at every student at the university? Well, what if our population, we define it as every freshman in Oklahoma, or beyond that, every freshman in the United States? We're not going to be able to study all of those people. So therefore, we have to get a group of them, a subset, and that will be our sample size. Okay, so two important concepts to understand: population and sample. When a sample is taken from a population, conclusions about that population follow pretty straightforward details. Okay, determine the information desired, identify the population about which conclusions are made, select a sample of subjects or elements from the entire population and extract the necessary information, statistically analyze the data, and from the results of the statistical analysis make inferences or generalizations about the entire population. So again, these are the 5 things that we want to understand. So the very first thing is we have to determine what information it is that we want. And by identifying that information, it's going to help us get to step number 2, which is going to help us identify our population. So if we are specifically looking at freshmen at NSU, and we want to look at something like what is the college? What is the entering freshman concept of homework or perceptions of homework at NSU? So at that point we know what we want to glean. We want information about perceptions of homework. We're only concerned about students at the university, so we've identified our population. Next, we need to select a sample of subjects from the entire population, here from all the freshmen, to get this necessary information, to ask them about their perceptions of homework. Then we're going to analyze that data, and if we've done all these things correctly, we should be able to generalize the results of our sample to our population. And that's a key term here. I should have put that in big bold letters. When we're talking quantitative statistics, we can generalize these to the larger population. Okay? Or infer is another word that we'll use. So that's what we're going to do. We're going to determine what we want, identify the population that we want to study using that characteristic or that information, get a sample of subjects from that population, analyze the data, and then from those results generalize our results back to the population. So it's all about the sampling then. It's easy to identify the population, but it's all about the sampling. So if you wanted to study student body about studying habits, let's say we wanted to study the student body in Tulsa Public about study habits, would it be a representative sample to choose, say, the first 50 students in the building? Pick a high school randomly and pick the first 50 kids. Or pick another high school and choose the kids who are in the library 2 hours after school on a Friday. How about if we chose one school and picked all the males? Or if we looked at the whole district and chose all the seniors who were applying for summer school in order to complete their graduation requirements? Or what if we chose members of the basketball team, male and female? Would we be able to get the information that we wanted? And here, if we go back, our number 1 is the desired information. That information is studying habits of the student body. Would these samples give us that? And the answer to all of these is obviously no, as you quickly figured out, I'm sure. The reason for that is because they're biased samples. we would assume that the first 50 kids in school are going to be more studious. And maybe the middle of winter and they may be cold, but in general we think of students arriving at school early or staying late as being more studious. All male students has nothing to do with being studious. It's just simply would be inferring that men are more studious than women, and so we're not going to study women. So anyway, you get the point. These are biased samples. So how do we avoid getting these biased samples? And we have to ask ourselves two questions. Number one, how do we select a sample from the population that is representative of the population? Okay, very important idea, concept. A representative sample of our entire population. And number two, how big does it have to be? So let's first talk about how we're going to get a representative sample. So we're going to talk about 4 techniques here. The first one is called random sampling. And this is simply randomly assigning numbers to students, drawing names out of a hat, and so forth. There's some randomness to it so that you are not biasly picking certain students. Okay, you have no idea who the students are when you're looking just at numbers, and you're going to draw names out of a hat or so forth. So randomly sampling gives us a very free way to choose a representative sample, and we'll see what we mean when we talk about sample size and the odds of us choosing a representative sample. The next way we call stratified random sampling. So if we wanted to random sample the student body at a high school, and let's say there were 400 students and we put all 400 names in a hat and drew them out. So first of all, I would say that as you draw one name, a student has a 1 in 400 chance of being drawn. Technically, if you don't put that name back, maybe you can mark the name out to show it's been drawn, but if you don't put that back, the other 399 students have a slightly better chance of being drawn because there will only be 1 out of 399 and then 1 out of 398. So to be truly random, you need to replace those that you draw out so that you can see that every student has an equal opportunity. But in theory, you would draw a representative sample. Let's say you want to draw 40 students. You would hope to get 10 from each class. You may not if there are 100 in each class. But if you did a stratified random sampling, that might make it easier for you to get your students, because at that point you can say, okay, I'm going to divide them into 4 groups, and I'm going to choose 10 from each class. So I've got my 100 seniors, and I'm going to choose 10. I've got my 100 juniors, and I'm going to choose 10. So through a stratified random sampling, you will purposefully get samples from each of the strata that you decide, however you decide it. It may be class. You could do it by gender and say, I want to get an equal number of males and females. The next way is very similar to stratified random sampling. It's called cluster sampling. And this, we're going to cluster groups around natural barriers here. So a common thing would be to say we're going to do this by states or by schools. We could do it by buildings. So if we were to pick Tulsa Public that has 8 or 9 high schools, we might do a cluster sampling and say we're going to choose students from each school to represent the total student body in all the high schools in Tulsa Public. That would be a cluster sampling because you're stratifying around specific natural barriers, and that's the key there. And the last one we'll look at here is a systematic sampling. Randomly done by a plan. So you're going to do random sampling, but you're doing it by a plan. So you might say, I'm going to assign every student a number, and I'm going to pick every 10th number. Okay, so randomly assigning them numbers, and then say I'm going to pick every 10th number. Or you could say, I'm going to alphabetize the student and pick every 10th student in alphabetical order that appears in alphabetical order. So that's a systematic sample. You can see how it's called that because there's a systematic way of organizing the data. One thing that's not on here that probably we see the most at undergraduate level would be convenience sampling. We see this quite a bit at the graduate level for master's degrees. And convenience sampling is simply stating, I'm going to use the most convenient sample that I have. It depends on how you define your population, but convenience sampling probably is more biased than the others. But anyway, that's a reality that we face in beginning statistics and working with quantitative research. So these are 4 ways. We're not going to add convenience sampling on there. These are 4 sampling techniques. So now the question is, how large of a sample do we need? If we say we have 500 freshmen, or actually let's say we have 2,000 freshmen at the university, if we want to understand study habits of the freshmen at NSU, and that's our population we've defined, how large of a sample do we need? Okay, we're just going to randomly select them. So it's a random sampling. We're going to put all their names in a list. We're going to put that list in a big bin, and we're going to mix them up and randomly pull out names. How many names do we need to pull out before we can feel that we have an adequate representation of the freshmen? So 2,000 students, keep that in mind. So this is the chart that you have in the module or on your syllabus. This chart is used to determine the sample size little n from the population size big N. Okay? So remember here, in an ideal world, a sample size smaller than the population will always have some degree of error. And the smaller you get, the more error you have. If you have 5% of the population will not reveal generalizations as well as 80% of the population would. Okay? So there's a trade-off between the size of your sample and the accuracy and ability to obtain that sample that you can get. Okay? So we use the sample size chart that I have here for you to determine what our appropriate sample size is. So big N is our population, little n is our sample. This chart has been developed 60 years ago and is set at a 95% at 0.95, which means that out of 100 cases, we're willing to say that 95 out of 100, or we have a 95% chance that we will collect a representative sample of the population if we have the minimum number. So if we have a population of 100, then we need to get 80, and we can have a representative sample. Notice that as our big N goes up, so does our little n, but it goes up at a much slower rate. If we said we had 500 students, we would need to sample 217 of them at a minimum to feel 95% sure that we can generalize these to everybody, that it's representative. We said that we had 2,000 freshmen at NSU. So in order to get an idea of their study habits, we can look over here and see that we need to collect a sample size of a minimum of 322 students. The reason this chart is important is because this chart will give you, or this chart tells us why sample sizes are often given. If you look at national polls will often give you a sample size, and you can see that according to this chart, if your population is 1 million, you're at 384. If you go in and start looking at data and try to figure out, there are online calculators now that will tell you what your sample size needs to be. They will typically ask you for your error, and we'll talk about that in the next module, but basically this is that plus or minus percentage. So when the news media says, hey, we've done a poll of potential voters, and they say that they choose candidate A to be president with a margin of error of 4%. Okay, we're going to talk about what that means, but now you can understand, looking at this, why that sample size could technically be a small sample size and still be representative of the population. So one of the things, and we'll spend a lot of time on this, one of the things to remember is that there was some criticism in the 2016, I think it was 2016 election, about some news outlets using polling data, and why did the polling data go so wrong. And I finally saw a story that said the polling data was typically looking at the numbers they called to do these polls, 2 and 3 question polls, to make predictions about candidates in elections, were mostly or all landline numbers. Well, in 2016, most people didn't have landlines anymore. If they did, they didn't answer them. They all used their cell phones. So those polls were not representative of the population. Even though you had a good small N, the polls themselves were not representative because the people, most people now don't use landlines anymore. And so those who still had their landlines were, you think of typically older people who don't use cell phones and so forth. So they weren't representative of the population. But anyway, that's getting off in a rabbit hole way too far. The main thing here is I want you to see that there are predefined sample sizes that you need. So the last thing here, notice n equals 1,000. If you define your population as 1,000, then you need to sample 278 people out of that population. If your n is 1 million, you need to sample 384. And that slowly, very, very slowly goes up from the 384, so that you're practically still around that number when you get up into the millions, not just 1 million, but multiple millions. So, 2 last words here that you need to know. And these are parameters and statistics. Okay, now we've talked about statistics before, but we're going to look at it now in the way that we are going to use it for the rest of the class. First of all, parameters. Parameters are quantitative characteristics about the population. Okay? In general, they cannot be known. The fat content of hot dogs from a certain company. In theory, you could look at the fat content of every single hot dog and determine that. But we're not going to do that. The median height of all high school baseball players in the United States. in theory, you could do that, but we're not going to do that. Another example of parameter, we could look at the mean fuel cost of every flight around the world in a given day. Again, that might be a little easier to get, but that's still a ton of data that's going to be very difficult to get. So these are things within the larger population that are unattainable because the population is so large. And so even though they're quantifiable, we cannot generally know them because of the population and the size of it. And these characteristics we call parameters. Statistics, on the other hand, help us define those parameters. So these are things that we can draw from samples, not population. So we could look at the median height of the Oklahoma City Thunder basketball team during the last season. And that might give us some type of generalization, but we could get that. And it might give us a type of a generalization to a larger population. The percentage of left-handed students at a specific high school. You know, we could easily get that as a sample and make inferences to the larger population, whatever we could infer from being left-handed. The average ACT score of a junior class at a particular high school, last year or this year, doesn't matter. These are things that we can easily obtain as a sample, and depending on the size, we can infer them to the larger population. Okay? So the big difference then is that parameters are quantitative information you do not have on a population, whereas statistics is the quantitative information you do have for your sample. So let's talk for a second about what we did in our last few modules. So the average height for a man in the United States was 69.1 inches, or 5 foot 7.5 inches tall. The standard deviation for male height in the United States is at 2.9 inches. Somebody did not go out and measure every man in the United States. Okay? Now, in theory, you could do that, but that's a parameter. It's a quantifiable data set that is just not going to be known. So our population then we're going to define as men in the United States. Our sample size was used to make that inference into the population. So the statisticians who have determined that the average height of a man is 69.1 inches had a sample that was large enough that the results of their analysis could be inferred or generalized to all men in the United States. This allowed the data to be generalized to all the population. The statisticians took the sample data and they found things like the mean, the median, the mode, the variance, and the standard deviation. All of these things that you can now do since we started our course. Okay? And added to that, we could add that individualized side of statistics, descriptive statistics, where we can now look at converting these raw data into standardized scores, and which you did in the last module, and you were able to say that you thought there were about 85% of the men in the country taller than me. Physically, that might be true. Mentally, I don't see it. I'm at a complete loss. I think it might be the other way around, but that's just me. So I don't take offense that you told me that I ranked down in the 15th percentile. So anyway, again, chasing down too many rabbit holes here. So the results of these operations of taking these raw data and from a sample that is representative of the population and is large enough that we can generalize it to the population, and finding things like the mean, the median, mode, variance, and standard deviation, all these things that you know, the result of all this is called statistics. We can take this information that we get then and we can infer it to our population. These statistics will be used then to estimate the value of the corresponding parameters within the population. Okay? So we're going to estimate what we think the average height is of an American male based upon a random sample that is large enough, and these statistics that we did, we're going to take those results and we're going to estimate what those parameters are for the population as a whole. And in this case, our population is all men in the United States. So one final thing here. Now that we're looking at these two distinct things, the population and the sample, up until this time we've been using Greek letters to define things like standard deviation and so forth. But now that we're bringing in samples, we get a little bit more specific. So we're going to use English letters to define statistics or to describe our samples, and we're going to use Greek letters to define our parameters or discuss our population. So what that's going to look like is we have an S, just a little S when we're talking about the standard deviation of the sample, and we have the lowercase Greek sigma when we're talking about the standard deviation for our population. Okay? We're going to have X bar when we're talking about the mean of our sample, and we're going to have the Greek letter mu, mu, the lowercase mu for the population mean. Okay, so X bar is our sample mean, mu is our population mean. And finally, we're going to have S squared is our sample variance. And you remember from a couple of modules ago when we did variance and standard deviations, sigma squared was our population variance. Okay? So let's review then what we said our goals were for this module. Distinguish between a population and a sample. We're going to pull a sample from our population, however we define our population. Describe the role of sampling and inferential statistics. If our sample meets certain criteria, the size, an unbiased sample, then we can run statistical analyses on that sample, and we can infer, hence inferential, we can infer those results to the population. Discuss 4 common sampling techniques, and that's where we started off with random sampling, stratified, and so forth. Explain the importance of representativeness in forming a sample. We talked about the importance of guaranteeing that if we chose 100 students or 40 students from a student body of 400, we wanted that representativeness, and so we might go to a stratified random sampling in order that we truly want all students represented. So we're going to choose an equal number from each grade level. Okay. Determine an appropriate size, a sample size little n for the given population size big N. Explain the relationship between the sample size and the size of the population. Identify biased samples. Identify important characteristics of random sampling. This we did not discuss. This is kind of not there anymore. This is a little bit dated information. The role of computed statistics and inferential statistical work. We're going to get into some of that stuff later. Finally, contrasts of statistics and the parameter. Okay, so those were our goals for the module. You will be happy that we're sliding away for a short time on, I hate to say difficult math because we haven't had anything difficult yet. Multi-step math. How about that? So And we really haven't even had that yet. But anyway, nonetheless, your assignment for this is some short answers and using that sample size calculation sheet. So best of luck. Next week we'll move into estimation and how we go about taking results from the analyses that you already know how to do, mean, median, mode, variance, and standard deviation, and making estimates toward the parameters of those characteristics to the general population, among other things.